Welcome to week 4. And as two quick announcements, one classmate didn't know about the low-cost internet resources. So let me share that real quick in case it helps anybody. If you go actually to the study skills page, the light bulb, then scroll down a little bit and there is a table of contents on the side, free or low-cost internet. And some of this is Oregon specific, some of it isn't. But there's ones from Comcast and Spectrum and AT&T and the Oregon Public Utility Commission. So if that helps you or someone you know, then read that, click there, find out more about it. Then the other thing I was going to do announcement-wise is we're moving on today in Mad Science. We've done only fraction arithmetic, multiplying, dividing, addition, subtraction. And I'm wondering if as we go through these topics, would it be more helpful to keep going like we are with just one long video for all of our class time? Or should I stop and try and make the links in the syllabus folded down topic by topic? Are people searching for only order and terms and having trouble finding it? Or is that not a problem, so it actually doesn't need any fixing? What do you think?
I think it's working.
Yeah, I think it's fine.
It's fine as it is? Okay, well, since I sometimes forget to hit record, then having me do that fewer times is probably smarter if we don't need to fix anything. Okay, well, onward like we are then. Just to recap, we did shape shifting, and some of that, probably a lot of that was review, but hopefully explained in a more robust way than you've seen before. Then we did a shapeshift test together to sort of cap that off, make sure we really understand things, and we're moving through Mad Science. Were there questions on the fraction arithmetic before we go on to the next topic?
I'm good.
That actually seemed to be, one of the easier homeworks. I have several students have turned in. I'm misspeaking. It wasn't that. It's the last of the measurement. Lots of people have turned in measurement, even if they didn't get all of the other 3. This one, no one has turned in because, or maybe one person has turned in, but it wasn't supposed to be due yet, so that's fine. Okay, mixed number subtraction, new topic. And this is mostly actually about place value. We're using numbers, mixed numbers, but to have an excuse to talk about place values. So there's 2 ways to think about subtracting with mixed numbers, and the first uses place value a lot. So we're just going to pretend that place value is happening. So first, I'm just going to do a problem with place value subtracting, and we'll do 31 and 22. And I know you know how to do this, so just bear with me. I am putting it on the board for a format reason, not because I am trying to teach you anything new. But the way I think about this is I look at my 1's place and my 10's place as separate things. And I am trying to subtract. I could subtract 3 10's minus 2 10's. I have no trouble doing that. But I want to start from this side, right? Start from the right and go left. Because in this particular problem, I can't subtract starting with 1 and take 2 away unless I go negative, which would not be what I want to do. So in my 1's column, I get stuck. 1 minus 2, that's not what I want to do. So the solution is to borrow. I'm going to say this 3, I will break apart. By the way, it's not really a 3, it's really a 30, right? Just like this 2 is really a 20. So I'm going to take this 30 and I'm going to make it 20 plus 10. And then I'm going to take that 10 and put it in the ones column. So this 10 and this 1 go together now. I have 11 ones in my first top number and 20 left over. Then I will subtract. 11 minus 2 is 9. 20 minus 20 is 0. And I get 9 as my answer. And I've made a terrible mess. This is not how you would normally write it, but hopefully my narration was good review. What I would normally write is just 31 minus 22. I would say, oh, let's borrow that. Put a 10 up here if you were taught that way, or just change the 1 to be an 11 if you were taught that way. Which one do people like better, or do you write it some other way?
I like the 11.
I wrote it a different way whenever I was doing it.
Is there some way that makes people happiest if I do it? I don't really care. This is about the only time I will ever write this.
No, I think it's good.
Okay, I'll just put 11 then. So 11 minus 2 is 9. 2 minus 2 is 0. Maybe I put a 2 up here, like that. So we're going to do the same thing now. So our problem is that we're cutting from a board. We start with 3.5 inches, and we want to cut off 2 1/4. That's not a problem at all. We don't need to borrow. If I have 1/2 inch and I get rid of a 1/4 inch, maybe I want to draw something. I have half of something and I want to cut away a 1/4. That's gone. What's left? Just the 1/4 that I started with but didn't take away. So 1/2 minus a 1/4 is a 1/4. And 3 minus 2 is 1. I'm treating it like place value, starting on the right-hand side, working my way left, 1 column at a time. On the other hand, if it was a slightly different problem, now I need to borrow. I only have a 1/4 inch. I can't take a whole 1/2 away from that. So what should I do? I will do the same thing as before. I will take my 5 and I say that's actually a 4. And then I also have 4/4 up here. I broke my 5 apart. 1 hole or 4 holes stayed here, and 1 hole I changed to be 4/4. So I have 5/4 now for this kind of top corner. My 1/2, I can change that. And that's 4/4. I'm sorry, 2/4. I can do math. Okay, so 5/4 minus 2/4 is 3/4. 4 minus 3 is 1. And I'm using the same thinking I'm doing over here to do a fraction problem. This is one place value column. This is another one. It's not really place value because that's a phrase we use to talk about decimals, but we're thinking the same. As a side note, if you don't like that, that's fine. You can do the same problem thinking about things only with improper fractions. I could write this 5 1/4 minus 3 1/2. 5 times 4 is 20, plus 1 is 21/4. 3 times 1 is 2, plus 1, 3 times 2 is 6, plus 1 is 7/2. And just like we learned with fraction subtraction last time, doesn't matter if they're fourths or oranges or hippopotami, If I have 21 of them and I take away 14, I have 7 of them left. These answers look a little different. When you treat it like place value, you'll more naturally get a mixed number answer. When you treat them all as improper fractions, you more naturally get an improper fraction answer. But they're the same. 7/4 and 1 3/4 are the same. So this is something else that, just like all those different ways to deal with multiples, you don't have to be able to reproduce both of them. Pick your favorite style. I'm going to do place value, or I'm going to do improper fractions. But you should be able to follow along so that if your next math teacher or some problem on the GED has one style, then you can at least understand what they're doing, what they're asking of you, what the example problem is about. Questions on those?
I'm good.
Okay, very short section. There's a video. Once we get your book, there's homework. I have a division meeting with ABSC later this week. I'm going to nag them about where's your books. Okay, order and terms. And this one has some stuff in chapter 1, section 7. So if you've been itching to use the textbook, then you finally can. Okay, this one, unlike the previous topic, is very important. So I'm going to slow down and try and do things right. There is an acronym that many people know called PEMDAS, PEMDAS, and we are remembering different types of arithmetic: parentheses, exponents, multiplication, division, addition, and subtraction. And if you are taught this well, it can be a very nice, helpful tool. But if you were taught this poorly, then it can cause you to do things wrong. So we're going to go slow and careful and make sure that everyone has seen this the right way now before we move on. So my problem is 8 divided by 4 times 2. So let's take a vote. Some people might say that the right way to do this is to look at the PEMDAS acronym. And we start over here, parentheses, there aren't any. Exponents, there aren't any. Multiplication. So we'll do the multiplication. 4 times 2 is 8. And then 8 divided by 8 is 1. And there's other people that will see the same problem and say, this is a left to right problem. We'll go 8 divided by 4 and get 2. And then 2 times 2 is 4. So 2 different answers. Obviously, only one is right. Which one do you like, top or bottom, and why?
I like the first one.
Top.
No other votes? Okay, before I tell you which is right, we should realize that when we say which is right, it's not like the same kind of right as 2 plus 2 equals 4. Right? No one had to invent 2 plus 2 equals 4. It's just if we're counting things, that's how counting works. Whereas this is something about when do we need to write parentheses? If I want to, I could put parentheses around the second part to show that's what's first, or I could put parentheses around the first part to show that's what's happening. So somebody sometime long ago had to make a decision, which of those parentheses are a waste of ink? I don't really need to write those. One of them we'll just assume is the right way. So this is only about notation. It's not kind of how the world works, how numbers fit together. But the answer that people picked is that some operations have equal priority. Multiplication and division actually have equal priority, and addition and subtraction have equal priority. So if those are all that's left to do, we go left to right. So on our Jamboard, this one was actually the wrong way to do it, and this one was the right way, because multiplication and division are one thing, and addition and subtraction are one thing, even though there's two letters there. So let's look at more of that. Before we start looking at more problems to solve, then we should realize that PEMDAS doesn't mention fractions, but that's okay. It actually kind of does. Anything you give me with a fraction, like this thing with the red numbers on the screen, I could rewrite with parentheses, because fraction bars are just like division symbols waiting to happen. Remember the shape-shifting part of the online notes that had Snoopy on the doghouse waiting to pounce. So if we have 8 minus 4 as a numerator and 3 plus 1 as a denominator, we could write that as something divided by something and just use parentheses to show how big the sections were. So if we really wanted to fix PEMDAS, then we would have something like this, but no one ever writes it this way. So parentheses and fraction bars are one kind of thing. Exponents are one kind of things. Multiplication and division are one kind of things. And addition and subtraction are one kind of thing. So we're doing 4 things in order, even if they have multiple letters for their kind of thing. But again, no one writes this. You can't search for it written this way with F and parentheses in it and find it anywhere else. This is just me lecturing at you. So think about it the right way. Maybe you will be a vanguard trendsetter and write it this way, but most people just write it PEMDAS, and that's fine. Okay, that was long and awkward. Is there a better way to do things? And the answer is yes. Before we actually do any problems with PEMDAS, we're going to talk about terms. So let me grab that. A term is a part of a long expression that's separated by the equal sign only with addition or subtraction. So actually, I am going to open this in another window so I don't have to keep making it wide and arrow on you, because that must look really awkward. Okay. So let me talk about terms more. So in this problem, I'm going to start at the left, because that's normally how we read math. So 4 plus 2, that's addition or subtraction, but it's inside parentheses. So I keep going. Divided by 3. Here is a plus or minus outside parentheses that breaks this up. And then we have 8 and a multiplying, and they get to the end. So we have 2 terms in this expression. Doing something a little more complicated. Then it's not harder. Don't be distracted by what it looks like. I'm just going to go along, multiplying, multiplying, multiplying. Here is an addition or subtraction that's outside of parentheses. So that makes a break between terms. La, 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 la. That one's inside parentheses. Oh, there's one. There's an addition or subtraction that's outside parentheses. So that breaks it apart. And 5 is its own little term. That looks kind of deep. Okay. So this one has 3 terms. Okay, your turn. I'm going to paste one on the board over here. How many terms are in 48? We'll do it together, but first I want you to try it yourself.
Five.
5. Is she right? Anyone else have a answer yet?
I got 5 too.
Okay, where does the first term end? I know it starts at 11.
It ends at 11 too.
Right there. Okay, so then I keep going. Do. Tell me when to stop.
2.
Stop.
Okay. Do.
Right there. 7.
Listen.
That's a 3.
Okay, yes, 5 terms. Everyone okay so far before I wrap it up into a nice package?
Yes.
Yeah.
Okay. So the nice thing about this then is that all the terms, oops, actually I don't want all of that. I just want to actually solve it. All the terms are independent. And we just had a little too much going on with PEMDAS. What we're doing is saying the addition and subtraction we're going to save for the end. So we only have 3 things to worry about: parentheses and fraction bars, exponents, and multiplying and division. So actually, I'm going to rewrite this so it's really big. Okay, so we already found out that this was 1 term and this was 1 term, right? That sort of broke it apart. So those are separate. I can just put a plus kind of going down the page. And whether I do this part first or this part first doesn't matter. Everyone does this part first just because we're used to working left to right in math problems, except for the place value subtraction. But they're totally independent. Okay, so whoops, I drew things one scolded me. There we go. Okay, so plus 2 is 6. 6 divided by 3 is 2. We've gotten that term down to just 1 number. What is 2 squared?
4.
4.
4. And 8 times 4 is 32. And we've gotten the second term down to 1 number. And then we can just add them up. 2 and 32 is 34. So I'll do another one, and then guess what? It will be your turn. So 1/2 times 4 times 5. Now I, as a person who has done this a lot, have a habit. Just like when I am doing fraction arithmetic, I leave some space when I'm adding or subtracting fractions so that I have room to unreduce things. Remember how I would write things like 1/6 plus 1/12, and I left some space here, knowing that there's going to be times something on the same top and bottom, right? So when I write these long expressions, then my natural habit is to leave space around the plus and minus signs outside of parentheses that break things up into terms. That's because I normally, when I'm not lecturing, don't actually underline the terms. Instead, the space helps my eyes see that there's three separate independent things happening. So I encourage you to get in that good habit. Leave extra space as like cushions or padding so that you can really see what the terms are. Okay, so minus and plus. This one might need 4 lines, I don't know. This is obviously the most complicated one in the middle. Let's start with that. So 9 minus 1 becomes 8. 2 times itself is 4. Now we're back to that warm-up thing. I have multiplying and dividing. They're the same priority, so I'm just going to go left to right. So 3 times 8. 8 and 8 is 16. Another 8 is 24. And 24 divided by 4 is 6. 1/2 of 4, that's 2. 2 times 5 is 10. 10 can stay 10. And this 5 just kind of hangs out, waiting for the other ones to catch up. Then 10 minus 6, 4, plus 5 more is 9. Okay, questions about either of these before it is your turn to do one?
I'm good.
So this is the one we did before. You've already told me that there's 5 terms. Oops, I got a little bit of blue line. Let's see if I can get it better. Okay. So I'll write it big for you. 11. I'm putting some space as I write things. That's a little sloppy. Okay, so work on that bit. I'll pause the recording and then we'll do it together. Okay, if you got 20, you did great. So I'm going to again say all of these terms are independent things that will come together at the end. Well, the 11 is just a number hanging out. 8 times 2 is 16. 14 divided by 7 is 2. 19 divided by 4 is going to be a 15. And then divided by 3 is 5. And lastly, 3 times itself is 9. And 90 divided by 9 is 10. So 11 plus 16 is 27. Take away 2 more, or 2 from it is 25. Plus 5 is up to 30, and then down 10 is down to 20. Hopefully you have calculators or cell phones with calculator apps, or if nothing else, the link on the top of the websites to the Desmos calculators. You can just plug these in and have your calculator do them. It is not like you will ever be building a giant battle robot and it crashes and doesn't destroy Tokyo because you did your math wrong, right? You don't have to do this by hand. But it's nice to know that you can do it by hand if you had to. And hopefully this technique, breaking things down into the terms and letting each term be its own part of the problem, makes it so that it's nice small pieces that fit together well. Okay, questions about this one while it's all on the board?
I'm good.
As one final warning, you can cancel factors when you multiply fractions, but you can't cancel terms. Terms are, by their very nature, stuck together with plus and minus, and canceling doesn't work that way. So there will be students that see something like in this top row on the screen, and they'll try and do canceling, but there's no multiplying happening. So no, can't do it. Okay, you have videos, you have textbook problems, and that's all there is for that topic. So the next thing I want to show you is something that's not important, called a goes with chains, about which numbers go with each other. We are going to learn later on a better way to do this kind of problem. So this isn't something that we want to really study and practice a lot so that we have the technique down pat. We don't care about this technique. We will get a better technique later. But just to help our sense of how numbers work and what rates and ratios are, then we want to talk about this now so that we'll understand later things better. Oops, none. Okay. So you get these word problems sometimes. I'm sure that the GED has this kind of thing where you get all of these different rates and you have to somehow smash them together. And that's okay. We're in mad science. We're learning how to smash numbers together. So if I was to list them out, then we have 7 hours per one day, 60 miles every 1 hour, $3 for every 1 gallon, and 20 miles for every 1 gallon. So I'm just reading the word problems, and whenever they say per, that's a rate. 7 hours per day, 60 miles per hour, $3 per gallon, 20 miles per gallon. So these are the 4 things that I'm asked to smash together as a mad scientist. I'm not quite sure how to do that yet, but they are like 4 different chemicals in a test tube in front of me on my lab bench. The problem that I'm being asked specifically is how much did she spend each day on gasoline? So I'm going to want to write that very simply. And the way my brain works, I just want to write, actually I'll put it in green, 1 day equals how many dollars? That helps me keep track of what I'm looking for. Because often when I read a word problem, then it's just easier to sort of summarize it. 1 day is blank dollars. If I can fill in the blank, I'm good. Everyone with me so far before I actually get started?
Yeah.
Yeah.
Okay, so, well, what I have is 1 day. So I will take that one. 1 day. And there's a symbol you probably haven't seen before that looks sort of like a fish. So 1 day goes with 7 hours. And where did I get that one? That was this one, right? So I've used that. I can check it off. Now I want to keep going. What does 7 hours go with? There aren't any hours here. There aren't any hours there. The only one with
Miles.
hours is this one, right? And it's a 1 hour. So I'm going to say, let's do, actually, I'm going to change my check mark color because I want to use yellow for fraction unreducing because that's my habit. So I'll do a times 7 top and bottom. I'm allowed to do that to fractions. So 7 hours becomes 7 times 60, which will be 420. And now I have used that one. I'm not going to need it again. Okay, 2 more. Which one do I use next?
$20.
Yeah, the 20 miles one. It's the only one with miles in it. This one isn't going to help me keep going. I don't want 20 miles, I want 420. So I have to multiply it by 21. So multiply by 21, top and bottom. So 420 miles goes with 21 gallons. And now I've used that one, it's checked off. Lastly, $3 for 1 gallon. I don't want 1 gallon though, I want 21. So I will multiply 21 by the top and bottom. $21 times 3 is going to be $63. And I've used my last thing, I check it off.
For
So
the
that was a
$3
fair amount. Go on.
for the $3 over 1 gallon, why do you want it to be 21?
Because I was starting with 21 gallons, so I had to make this 21 gallons.
Oh, okay.
So this was a fair amount of work. I had a lot of stuff to do, but I never really had to make any choices. It wasn't like I could, have a brain fart and do the wrong thing, as long as I'm following the process very slowly and carefully. So that's good. A process that's pretty fail-safe, if you follow it slowly and carefully, means we don't get things wrong on tests. Let's do another one. So 6 friends want to order pizza. Each person will eat 4 slices. A pizza has 12 slices and costs $14. How much will they spend? So first tell me what rates, whoops, am I going to list on the side?
Is it 6 over 4?
Is it 6 over, well, there's no 6 on the word problem. Oh, there's the 6 friends. The 6 don't matter. That's actually a red herring to distract you. The 4 slices matter. What does 4 slices go with?
1 person?
1 person, yeah. We'll get to the 6, but not quite yet. Okay, what's another rate I have? 2 things that fit together this much per that much.
12 slices and $14.
Yeah. And they both go with 1 pizza. They might go with each other, but if they don't, they can certainly both go with 1 pizza. Okay, now I want the 6 because it's asking me how much will they spend, and the they is all 6 of them. So the question I'm really answering is 6 people is how much money. If I can fill in that blank, I've done my job. So 6 people is what I have to start with. Which of my 3 rates am I going to use?
4/1.
Yeah. I can't use it as 4/1. How do I need to unreduce?
Would you multiply by 6?
I do.
to the 4?
I need 6 people, so I have to do a times 6. And if I do it on the bottom, to be fair, I have to do it on the top. So now I have 6 people goes with 24 slices. And that one I've used, I don't have to think about it again. Okay, now what? I'm not at money, I have to keep going.
Is it the 12 slices?
Yeah, and it looks like we could have done this easier. Some people were saying that I just wanted to do it 12 slices is $14, and sure, we'll give you that. It works out fine. So I don't want 12 slices though. What do I need to do to unreduce this one?
Times by 2.
2. And if I do it on the top, I have to do it on the bottom. So 24 slices goes with $28. Ta-da. You want to try one on your own, or are you happy to just have me watch me do 2 of them?
I'm gonna try one on my own.
Okay. I am glad you're up for it. Again, if this isn't your cup of tea, that's not a problem at all, because we'll get a better way of doing these. But it's nice to show off that you can do these. So I will pause the recording, work on this a bit, and then we'll keep going. I'm actually going to do this in the other order. I'm going to say, how much permethrin should he use for 1 quart of water? So what we're looking for is 1 quart of water is how many teaspoons of permethrin. So that's where we start. Maybe that helps somebody that didn't get 2 teaspoons. Pause it again if you're watching from home and need to pause. But here we go. Okay. So 8 teaspoons is 1 gallon. And the other rate we need is how to connect the gallons to quarts. Who remembers that from what we did earlier?
Or quart.
Yes, 4 quarts in 1 gallon. And these are going to be of water. Okay, so we start with our 1 quart of water. This is the one that has quarts of water, but 4 is too big. So I'll divide it by 4, top and bottom. And that gives me 1 quart. And 1 quart goes with 1 divided by 4. Should I rate this as 1/4 or 0.25? Anyone care?
I don't care.
I'm going to expect that for some people, 0.25 is easier. If you wrote it as a quarter, that's fine. Okay, I've used the bottom one. Now I have to use the top one. I have a 1/4 gallon. So this is too big. I need to divide by 4 again. And 1/4 gallon goes with 8 divided by 4 is 2 teaspoons of permethrin.
How did you get the 4 quarts of water?
Because I was looking at in shape shifting when we went to the measurement unit history thing. Remember these pictures?
Yeah.
So 4 quarts is a gallon.
Oh, okay.
Okay. And I will put one more check mark. We use that one. Okay, so again, if you can follow me along, great. We're kind of doing this mostly to stretch your brain about that a certain kind of math involves taking a bunch of rates and smashing them together. And this isn't the best way to do it, but it's a way you can understand now, and your brain will be more warmed up and ready to go when we get to the actual thing we like to do. Okay, so where are we? Goes with chains. So no videos or textbook exercises with that. The textbook should do this, but it doesn't. Oh well. The 10 exercises have a bunch of fraction arithmetic. And then they have 2 kind of tricky ones. So think about those more. We don't have order of operation ones here, but in the random problems for what we've done so far, there's a nice order of operations. So remember those, the answers change every time and the numbers change every time you reload it. So get as much practice as you want. So this homework has no due date. I'll check on Thursday if we have questions about it. And if we do, then we'll keep working on it. If not, it will be due the next class, so a week from today. Okay, now we're on percentages, a new topic. Whoops. Before, everything we did with percentages was, of course, in the shape-shifting topic. So we talked about what you can do with just 1% at a time. You can change it into a percent, a decimal, or a fraction. Now we're going to be in mad science, and we're going to talk about what you can do with percents and other numbers and squish them together. So we're talking about percent of and percent change. And the 1+ trick is a trick to make percent change work better. Okay. Oops. Is the font big enough before I start reading to you?
Yeah.
Okay. The word of in a word problem tells us to multiply. You've seen that before, and that makes sense because making copies is what multiplication does. When you go to a store and you say, I would like 10 of those, what you're saying is I want 10 copies of one of those things. So tickets to an amusement park cost $25. A family buys 5 of them. What was the total cost? So 5 25s. How much is 5 quarters?
125.
Yeah. So this phrase, 5 of them, right? 5 and of turned into times 5. Grading a certain math test takes the instructor 7 minutes. A class of 30 students takes the test. How long will the instructor be grading? It looks like Emily is about to say the answer, but maybe her mic's not working.
Is it 7 times 30? So 210
It is.
minutes.
Yeah. So of 30 turned into times 30. That works with fractions too. If there was a sports program with 350 children, 3/7 of the children are boys. We could take the 350 and times 3/7, because of the children of the 3/7. So if you actually did that, you'd get 150. Rihanna eats 5/8 of a pizza, and her daughter Mitzi eats 1/2 of what's left. So how much of the whole pizza did Mitzi eat? So what is half of 5/8? Let's do that one actually as a review of. So 5/8, and we want 1/2 of that. Did we need common denominators when multiplying fractions?
No.
No. So just go across. 5 times 1 is 5. 8 times 2 is 16. Ta-da. But mostly we're talking about how of means multiply. Another occasion when the English language uses of to mean multiplying is percent of. So now we're actually where we're supposed to be. Let's do some more percent math. So what is 40% of 200? I'm going to take my 40% and I'm going to multiply it by 200. Unfortunately, on the calculators, the percent keys don't work very well. Maybe you have a calculator app that's extra special, but in general, you should always avoid the percent key. It does different things in different occasions. It is much more confusing than it's worth. We had this nice thing we learned before, riplop, that is better than trying to figure out how your percent key works on this particular problem. So we're going to go out of percent, left out of percent. It's always 2 scoops, and I will write 0.4. Then I can plug into my calculator, 0.4 times 200. We will get 80, and we're done. So that's our general process. One theme of this topic is these things called algorithms. When we're asked to find the percent of something, then the process is we'll use riplop to change the percent into a decimal, and then we multiply. Everyone ready to do a bunch?
Yeah.
Okay, so let's look at 3 different ones. Here's one where 200 seems like a nice friendly thing. Here's one where there's a labeled amount, 50 hours. Here's one, just to try and trick you, where the label happens to be another percent sign. So on all of these, I'm going to do riplop. And on all of them, I'm going to be going left to get out of percent. They all start with a percent. So my 60 is going to change into a 0.6. My 40 is going to change. These are all only tenths. I should make it like 45 and edit the website. 10%. Oops, that looked like 2 scoops. And then the of becomes multiply. Of becomes multiply. of becomes multiply. And then the other thing, 250 hours. And this second percent symbol is just a label like hours. I'm just going to have it hang out. If it helps you to write it as the word percent instead of the symbol, maybe you do that, whatever makes you happy. Okay, 0.6 times 200. 6 times 2 is 12. It's going to be a 12 with some decimals. Anyone remember the shortcuts? How many zeros do I have?
2.
I will have 2 from here. But then the fact that this is 0.6 moves me back 1. So I will erase the one that I did just dashed. And that makes sense because you're not going to get something bigger than 200 when you have less than 100% of it. Similarly, 0.4 times 50, I'm going to get 20 hours. And if you can't do these in your head, that's fine. Use your calculator. And 0.1 times 50% is going to be 5, and the percent just hangs out like a label. Questions about any of those?
I'm good.
So take your percent, do the ripple up 2 decimal point scoops, and then multiply by the other thing. Okay. When we're comparing percent of answers, be careful. This will happen a lot in real life where people try and mislead you because either they are confused or they are trying to mislead you on purpose. And the percent of things, it's easy to not notice when the things you're taking percents of are different. So come back to this after class, look at number 65 and think about that. But for now, let's go on to the switcheroo trick. And the switcheroo trick is a way to show off, especially at restaurants, and do things like calculate tips nicely. When I'm multiplying, it doesn't matter what order I multiply. And if all I'm doing is scooting decimal points left twice, I can kind of do that at any time also. So it works just the same if before I start, I move the percent symbol onto the other number. If you ask me what is 24% of 25, and I'm doing this the way that we just looked at it, I would say we're going left out of percent. So that would be 0.24. And I'm multiplying that by 25. Then now I'm kind of stuck. I'm not sure what that is off the top of my head. I don't know that. But if we changed it and said, what is 25% of 24? Then I know that 25% is just going to be 0.25, 1/4. And I know what a quarter of 24 is. What's 24 divided by 4?
6.
6.
So suddenly something that I couldn't do in my head, I could do in my head. Is it really important? No, I could take out my calculator and do it the top way just fine. But if you're finding restaurant tips of 10% or 15% or so on, then this could be a way to say, oh, I don't happen to know what 0.15 times some number is, but if that's something that would be easier to have the percent sign on it, then I'm good to go. As another one, a computer that costs 900 is on sale for 8% off. How much is the discount? And I don't know 0.08 times 900 off the top of my head. I would have to think about that a little more carefully. But if you ask me what is 900% of anything, 900% just means 9 of them, right? 100 is 1, 200% is 2, 900% is 9 of them. So what's 9 times 8?
72.
72. So I write it, what's 900% of 8? And that's 9/8. So that's a $72 discount. Okay, if you like the switcheroo trick, good for you. If you don't, that's okay. Because again, the calculator can always do this. It's just sometimes fun to show off. Tipping happens all the time. Actually, let me grab it from this. So we should talk about that. It's a very common application of percent of. Remember that to find 10% of a value, we would scoot the decimal point one place to the left. 0.1 times something was a 1-point scoot. 20%, well, that's just 2 10%. So I would first find the 10% and then double it. If I want 5%, well, that's just half of 10%. So I would first find the 10% with a decimal point scoot and then take half of it. And as a common thing for restaurant tips, to find 15% of a value, well, 15 is 10 and 5. So I would take the 10%, scoot the decimal point once, take the 5%, take half of that, and then add them back together. So let's do that with a few of these. So I'm asking a 20% tip. What is 20% of 25? So I would say 10% of 25 is just taking the 25, doing 1 decimal point scoot right, because that's the same as divided by 10. And 10% is the same as divided by 10. And I get $2.50. I want 20%, so I'm going to do another of that. And then add them up. And I get a $5 tip, which is 20%. When we did Riplop, by the way, we always scoot twice. We're moving in and out of percent. But this is a different thing. This is when we were back to decimal point scoots, and we were finding out that times 0.1 meant to go 1 spot to the left. Remember that from several days ago?
Yeah.
So don't get confused. We're not doing Riplop. We're not doing 2 scoots because we're not moving in and out of percentages. I'm not changing 20% to 0.2. I could do 0.2 times 25 and take my calculator out. But the whole point is that you can show off at a restaurant by finding the tip without getting your calculator out. Okay, let's do one more. A restaurant meal costs $30. How much is a 15% tip? So I want to find the 10%. So I take my 30, 10% for this reason is one scoop to the right. So that's $3. 5% would be half that. So what's half of $3? Oh, $1.50. And then put them together to get 15%. And I get $4.50. It's still true that I don't have to do it that way. I could say, what is 15% of 30? Use my rip lock to go out of percent and take out my calculator and say, what is 0.15 times, I'm using both times symbol zones, 30, and your calculator would tell you $4.50 also. So you don't have to know this tipping shortcut, but it can be nice to show off at restaurants. Questions about that? Okay, no one is asking questions, and I don't care about that particular topic enough, but I'm going to force a question on you just for the overview. You try this one, and then we'll, after the pause, check in and see what the answer is. Okay, if you got 21, great. So we're asking, what is 35% of $60? Notice that the original word problem didn't have the word of in it, but that's okay. As long as we can rephrase it to have 35% of something, then we know what we're doing. So get rid of that percent sign. .35 of becomes times. Oops. And we get 21.
I have a question.
Sure.
So the way that we're doing it, where the decimal point scoots over 2 times, can't you just do 60 times 35 divided by 100? And isn't
You
that
can.
true? Isn't that true for most or all percentages? For whenever it's saying like specifically this type of percentage, I
If
guess.
it's saying percent of, then yes.
Okay, I thought so.
Because it doesn't matter what order we do the multiplying or the scoop, it's going to get you the same. And by putting divide by 100 at the end, you're just putting the scoop at the end.
Thank you.
But that's a good segue. Thank you. So I want to do, where is it? To do the guppy problem. So what we're doing involves us being given a percent, right? It gives us 35%. It gives us 20%. It gives us 24%. It's possible to have an English question that has the word of and asks for a percent, but doesn't give you the percent. In a tank of 10 fish, 8 are guppies. What percent of the fish are guppies? There is an of. but we're not starting with a percent. So this is a different kind of problem. We'll get to this kind later. So just because you see the words percent and of in the word problem doesn't mean you're going to start with a riplop and then multiply. Because what if there's nothing there to riplop? There's no percent to start with. It's what we're looking for instead. So just a heads up, we'll get to those later. Okay, videos. Our textbook actually needs problems for that. We're on a roll, percent change. So we have done percent of, we have done percent change, and what we're going to do percent change, and 1+ trick is just more percent change. So what if you are asked to find the percentage? We can do that. A candy bar that normally costs 75 cents is on sale for 15 cents off. What is the percent of the decrease? How would we do that one?
Would you
Would you
do-
subtract?
Would you subtract? You could find the new price by subtracting. Currently, it's 60 cents, but that's not what this problem is asking.
Would it be a 75 times 15 divided by 100?
Nope, because it's not the same way as before.
Okay.
would
That was when we were starting with the percent. I'll give you a
Would-
hint. When we started with the percent, we multiplied. If we're going backwards, we should probably do the opposite.
Just gets
Yeah. So we're going to do, there's two ways to think about this. It could be 15 divided by 75. Some people like that in their brain. Other people like to think of it as a fraction. We have 15 out of 75, like parts and wholes. In any case, if you do either of those, then 15 divided by 75 is going to be 0.2. That was looking too crowded. I have a good answer. 0.2 is the answer. My math is nice. But this problem wanted a percent. So I can do that. I can give them a percent. Now I am going into percent, right into percent, and they get 20%. If you liked thinking fractions, you would just be adding an extra step over here. But if you started right here and kept going, that's fine too. You don't need the fraction step. So it's backwards from what happened before. Instead of doing a riplop to the left to get out of percent and then multiplying, then we kind of go back this way. We undo the multiplying with dividing, and we undo the scoots to the left with scoots to the right. It's sort of like if I put on first my socks and then my shoes. To get undressed, I take my shoes off first, and then I can get to my socks. And that, Joel, by the way, is the reason we taught it this way and not the way you said it.
Fair enough.
So, okay, so that is our new process. And people like memorizing formulas, and often that's the wrong thing to do. But this happens so often in real life that it's worth it to memorize a formula. We have our change is here. And our original is here. It's the same as thinking part and a whole of a fraction. But if I say part and whole with a sale price, it might not make as much sense to people. So we rephrase it. The part is how much is changing, and the whole amount is how much you had to start with. And we divide. So that is our percent change formula. Now, someone mentioned subtracting before, which was a great thing to think about, because sometimes the amount that is the change is hiding. So let's look at this one. A candy bar that normally costs 80 cents is on sale for only 60 cents. What's the percent of the decrease? So I want to write change divided by original. Maybe I even label this percent change is change divided by original. But the change isn't listed for me. I can just look at it and see it. What is the change?
$60.
60. No, that's the new price.
$20.
20. Yeah. So this is going to be 20 divided by, and then which of these two was the original?
80.
80. So 20 divided by 80, plug it in your calculator, you get 0.25. That's the right answer. But they ask what is the percent, so I have to make it a percent, write into percent. And I get 25%. Okay, ready to do a few more?
Yep.
Yeah.
Okay. I can make this one a little bigger. Okay. The value of a house increases from 150,000 to 170,000. What's the percent of the increase? So first, are they giving us are they giving us a percentage, a percent of kind of problem, or are we looking for a percentage, a percent change kind of problem?
Looking for a percentage.
Looking for a percent. So I'm going to use my percent change as change divided by original formula. Then I think, are they nice? Did they give me what the change is? Or is it hiding?
It's hiding.
It's hiding. So I have to subtract and I get 20,000 divided by, now what's the original this time?
150,000.
Yeah, it's not always the bigger or smaller. Don't think about big and small. You have to see what it was first, because sometimes things get bigger when they change value and sometimes they get smaller. So we're getting about, if I round it, 0.13. And I'm not quite done since it wants a percent. Then I have to do riplop right into percent. And I get 13%. Everyone happy with that one?
Yeah.
Okay, a painting originally worth 200 increases in value by 3%. By how much did its value change? Is this they give us the percent, a percent of kind of problem, or is this the looking for the percent, a percent change kind of problem?
Looking for the percent change.
Other way, there's the percent right there. So this one, they gave us the percent. So this one is the percent of, I'm just going to say 3% of 200. Now I am going to riplop this 3%, not right into percent. Now I'm going left out of percent. Is it okay now that you see it?
Yeah.
Okay. Then, one moment. What happens if instead they ask us something different? In the top problem on the screen, then there was this hidden change, right? What if that's actually our job? So here is the same problem we just did, but they ask us something different. Now they're saying, what is the new value? So we would do the same thing. We would say, what is 3% of 200? Make that 0.03 times 200. And we get that it's a $6 change. But we also have to say, so the new value, I have to add that back on. The 200 is still there. So I get 206. This is similar to up here, where we had a hidden change. Of the 170,000 minus the 150,000 was 20,000. It's just that at the very bottom of the screen, we are the one hiding the change, right? So here is a diagram to help you with that. We started, let me actually put this on the Jamboard so I can point at it as I talk about it. And actually put it on this slide. So we started the class thinking that we are looking for a number. It gives us the change as a percentage. We want something like $6 is the answer. So then our question is, if it asks for the change as a number, does it just want that number? Or is it our job to combine it with the original and hide the change? So that's this kind of thing. This is the percent of problems we just did. Or they could say, what is the percentage? Like here. And when they ask, what is the percentage? Then right away at the beginning, did they give us the change? 15 cents off. Or did we have to subtract and work for it? So the orange is the percent change style of problems. And whenever you see these word problems with percents, think about these two layers of choices. Are they giving me the percent and I'm looking for a number? Or are they only giving me numbers and am I looking for the percent? Then if I am looking for the percent, do I have to find the change myself? Or is it right there? Alternately, if I was starting with the percent, once I got my number, am I done? Or do I have to put it back with the original? Ready for some more? I know we need more practice.
Yeah.
Okay, here's two that might look kind of similar. Let's start with our little chart on the upper right side. For 82, actually someone read it out to me and tell me where we are on this chart as you're reading it. If you didn't want to do math in class earlier, now's your chance to just read a word problem and get credit for participating.
If the population of the city of Eugene was 163,000 in 2015 and it grows by 5% over the next 10 years, what will the population be in 2025?
Okay. Thank you. And then which wing are we in here on my diagram?
Would it be percent of?
Percent of. Percent of is when we're looking for a number, it gave us a percent. And yes, it gave us the percent. Good job. Do they want merely that change, or do we have to do something with it when we're done?
I think just the change.
Okay, let's see. So percent of, I'm just going to take the 5%. Of means times, whoops, it's not money, it's people. So 5%, I'm going to rip-lop left out of percent. If I plug that in my calculator, what do I get? It's about 8,150. Okay, is that my answer?
No.
No, they want the whole population. So I have to take this and stick it back on. Ta-da! So this one was they gave us the percent. We were looking for a number. And when we had the number, we had to combine it. Okay, how about the next one? Eugene's population in 2005 was that amount. We also know what it will be 10 years later from this problem. By what percentage did Eugene's population increase between the 2005 amount and the 2015 amount?
Is it percent change?
It is. We're looking for the percentage. So I'm going to go right to that formula, percent change is change divided by original. Now, did they give me the change or is it hiding?
Hiding.
It's hiding. So it's going to be 163,000, 145,000. Do my subtraction. I get 18,000. Okay. Which of these two numbers is the original, the way this problem is asking things?
Would it be 145,000?
Yeah, that's the older dates value. And I get about 0.12. I'm rounding, I should use squiggly equals. I'm not quite done. What's my last step?
Ripple.
Doo-doo-doo. So that time, it did not have any percents in the problem. We were looking for the percent. And did it show us the percent or hide it? It hid it. We had to do some subtracting to find it. Okay, there's videos. There's some problems from the textbook once you get that. I could move on to the 1+ trick if this is all seeming like it's going very smoothly in your brain. I'm guessing we should stop though, because that was a lot of stuff we just did. And we can do the 1+ trick on Thursday. What do people think? Should we do a trick to make things easier, because easier is nice, or should we not stuff more new stuff in our brain because our brains are getting full?
I think we should do it Thursday.
Me too.
Okay, so let's look at the 10 exercises. The first of them are percent of. You could do those. This one, they give us the percent. That's going to be a percent of. And then with number 4, they switch. Now they're asking, what are the percents? Those are percent changes. And you don't actually need the tricks. The tricks just make it easier. Whoops, and there's normal, should be normal E. Fix that. Okay. So you could do the percent homework. It's not going to be something expected of you because it'll be easier with the trick on Thursday. But if your weekend is really busy and between now and Thursday isn't, then maybe you want to try and do all 10 of them right now. Random exercises, as always, if you need more practice, then here they are. Should we leave this up on the screen, take a little break because it's approaching 7:50, and come back in 5 or 10 minutes and work on these together?
Yeah.
Okay, 5 minutes, 10 minutes, what do we want?